Take 7.6G, 7.12A, and 7.4A. So, I'm going to show you a few things that I didn't show you in class. I'm going to go through, solve these problems, and away we go. All right, the point of a circle graph is to show how much each part makes up the whole. All circle graphs must equal 100%. That's incredibly important, because if we notice, cotton, wheat, and other, they all have a percentage, but corn does not. And the question is, how many acres of land are used for corn? So the first thing we need to figure out is the percent for corn. And the second thing we need to do is to convert that percent to a decimal and multiply that by the total actual value. Now, you will not always be given the total actual value in a circle graph, but when you have a question like how many acres, you will be given, and it happens to be 48 acres total. That includes the cotton, the wheat, and the other. But we want to know just about the corn, okay? So what we can do is we can sum the percentages and then subtract those from 100%. So 40 plus 20 is 60, plus 10 makes 70. So we're going to subtract 70%. That leaves us with 30% is corn. Now, we can't multiply with a percent. We can add and we can subtract. We cannot multiply with a percent. So we have to convert the percent to decimal. So we take 30%. So we're going to divide that by 100. And we're going to drop the percent. So all right, so 30% decimal equivalent is 0.3. And then we're going to multiply that by the total value so we have 14.4 acres of corn. So Maribel surveyed 55 people to find out their favorite type of music. The result is shown in the bar graph. Bar graphs do not have to add up to 100%. Bar graphs show something completely different. Bar graphs show the actual number of people per category, or the actual number of responses per category. Okay, and so the way we read a bar graph is we look at the top, and then we draw a line over, and we see that country music has 15, jazz has 12, opera has 10, rock has 18. All right. Because of the height. All right. So, based on the information, which type of music were chosen by 40% of the people surveyed? So we have 55 people surveyed, and then we have 40%, but we can't multiply with 40%. So 40% becomes 0.4, and when you multiply 55 by 0.4, you get 22. So we're looking for 22 people. Now, we look at our categories. Is any category exactly 22? The answer is no. So, if we want to know what 40% of the people prefer, we may have to look at more than one category. And if we look at jazz and opera, we'll see that 10 plus 12 equals 22. So, jazz and opera is the correct answer. So these graphs, these representations, you have to know how to read them before you can make use of them. And so bar graphs, whether they go vertical or they go horizontal, you're looking at the length or the height of the bar, and you compare it against the axis that measures the height and gives you value based on the height. All right, so 80 students at a picnic. Now, what we want to know is, chose pizza, then students who chose salad, right? But more importantly, how many more? So we're looking for a difference. So there's two ways of doing this. We could find out exactly how many students preferred pizza and how many students preferred salad, but then we'd have to take the percent, convert it to a decimal, multiply against 80, then we get the product, and then we subtract the smaller product from the larger product, and then we would find out. But there's a simpler method. Because both of these are in percent, both the pizza and the salad, we can just find the difference in percent. Convert that to a decimal, and we're going to take 0.2, multiply against 80, because we're looking for the number of students. How many additional students preferred pizza rather than salad? So we have 80 students. Times 0.2. And this means that $16 students preferred pizza more than the number who preferred salad. Okay. This one we don't even have to calculate, but we do have to understand how to read this graph. So here we have Mrs. Kelso's class and Mr. Bonham's class. So this is the minimum value, and this is the maximum value. The range equals the max minus the minimum. Okay? So there's another kind of range. It's called the IQR. So IQR stands for interquartile range. And that equals Q3 subtract Q1. The difference between Q3 and Q1. So when we say range, it's the maximum value minus the minimum value. When we say IQR, it's just like range, but we're only looking for the range within the box. And then we have the median right there. So, which statement is best supported by the information in the box plots? That means we have to read each statement and compare against the box plot. So the range of data for Mr. Bonham's class is less than the range of data for Mrs. Kelso. Well, if the range is the minimum to the maximum, we can see that Mr. Bonham's class is less because his minimum is above Mrs. Kelso's and Mr. Bonham's maximum is below Mrs. Kelso's. Or another way of looking at it, the distance between the two extremes is less for Mr. Bonham than Mrs. Kelso. So already I know that A is correct. But let's continue on. The data for Mrs. Kelso's class are more symmetrical than the data for Mr. Bonham's class. Well, just visually, Mr. Bonham's class, his median is between the two extremes. We can infer that his median may be closer to his mean, whereas her median is not as close to her mean because the median is not equally spaced between the maximum and the minimum. But the thing about a box and whisker plot is they don't tell us what the mean is. So we're only guessing at that point. But because we don't know the mean, we can't for certain say that Mrs. Kelso and Mr. Bonham's class are symmetrical at all. All right. So I would not want to select that. The median number of the data for Mr. Bonham's class is less than the median number of the data for Mrs. Kelso's class. So here's the median. Mr. Bonham has a higher median value than Mrs. Kelso. So that's false. We eliminate that. The IQR of the data for Mrs. Kelso's class is greater than the IQR for Mr. Bonham's. Well, if we take Q3 and subtract Q1, we're going to have a smaller value than Mr. Bonham's class if we look at Mrs. Kelso's class. One giveaway is the Q1 for both teachers is the same, but Mr. Bonham has a higher Q3. That means there's going to be more distance in this box, and we can tell by looking at this, the length of the box is greater with Mr. Bonham. And we're saying Mrs. Kelso's class is greater, so that is not true. So we eliminate that. So A is the only possible correct answer. Okay, this is the amount, the actual value of the whole. The circle graph shows Alan's activities during 24 hours. How much more time in hours did Alan spend listening to music than playing tennis? Well, music was 12%. Tennis, tennis, 10%. And since we want to know how much more Alan listened to music, we're looking for a difference. So that's 2%. So then we convert that to a decimal. And we find that G would be our answer. All right. So the number of pets per household. Mr. Anderson or Mrs. Anderson's class and Mrs. Murphy's class. All right. Here we got to calculate. So I'm going to say Mrs. Anderson's class, Mrs. Murphy's class. Well, let me move those over just a bit. We got to do the mean, the median, the mode, and the range. Right? For Mrs. Anderson's class, and Mrs. Murphy's class. So I'm building a data table. Well, the easiest one is mode. We can tell that the mode on each one is 1. I'm going to enlarge that just a bit. There we go. The median, we have to calculate that. The mean, we have to calculate that. The range, we have to calculate, but the range is next easiest. Range is just your maximum value minus your minimum value. So for Mrs. Anderson's class, 8 minus 0 is 8. And for Mrs. Murphy's class, 6 minus 0, that would be 6. All right, in order to do the median and the mean, we have to make a list of all the numbers. But I have another strategy. So I'm going to take 6 off. Okay. I'm going to take 3 off the end here. I'm going to take 6 more. And we are left with 2 1s. So we want to find the average. So the median for Mrs. Anderson's class is 1. And if we do the same thing, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That just leaves a 1 right in the middle. So Mrs. Murphy's is also 1. The mean is a bit different. And so I'm going to erase my hash marks. Now, there are a lot of individual numbers that I could write in a list from smallest to largest. But that would take a lot of space. And so what I'm going to do is I'm going to take each category and I'm going to multiply by the number in the category, and I'm going to put the products at the top. And then I'm going to add all the products. And then that's the first thing I'm going to do. That is a way I could sum all of these quickly. So 0 times anything is 0. And here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1 times 11 is 11. 1, 2, 3, 4, 5, 6 times 2 is 12. 3 times 3 is 9. 4 times 3 is 12. 5 times 2 is 10. And then we have 8, because 1 times 8 is 8. Now if I add 11, 12, 9, 12, 10, and 8, I get 23, 32, 54, 64, 72. Because the way I get the mean is the sum divided by the number that I added. I'm going to clean that up just a little bit. Well, how many did I add? Well, there are 1, 2, 3, 4, 5, 6, 7. So we have 7 zeros. We have 11 ones. So that's 18. And then we have 6. That's 24, 27, 30, 32, 33. And then we can repeat the same process for Mrs. Murphy's class. So 33, or 72 divided by 33. .1, and there's some more, but it doesn't matter. We're going to round it to 2. All right. Same process over here for Mrs. Murphy's. 0, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we have, 9, there's 9 of those, but 9 times 2 is 18. And 3 times 3 makes 9. 2 times 4 makes 8. 1 times 5 is 5. 6, and then that's it. So we add 15 and 18 is 33, 42, 50, 55, 61. And then there are 1, 2, 4, 7, 16, plus 15 is 31. Okay. So then we take the 61, divide it by the 31. So the 1 times 3, this makes 30, and bring down the 0. There we go. So we get 9 out of this. So we're going to round this off to 2. So we could leave this 2.1. But the thing is there's no such thing as a tenth of a person. So that's why I chose to round. All right, now that we have this information, we can test these statements right here. We can test those against the data that we have in our in our calculations. So the range of the number of pets per household for Mrs. Murphy's class is greater than that for Mrs. Anderson's class. So let's talk about Mrs. Murphy's class. Murphy has a smaller range. Here it says greater. That's false. The distribution, so we go to number 2. The distribution of the data is approximately symmetrical in both sets of data. Here it says approximately. And we know that we rounded on the mean, but the median and the mean are not the same. So I'm skeptical of that. That word approximately means close. Or is it close? Is it about the same? So I'm going to put a maybe on number 2. So number 3, the mode of the number of pets per household for Mrs. Anderson's class is equal to the mode of the number of pets per household for Mrs. Murphy's class. That's true because the mode in both cases is 1. So let's look at our options. So I know 3, our answer has to include 3. So we can eliminate that one. So we know that now we have a 3 out of 4 chance. Okay, we know that number 1 is false, so we can eliminate anything with a number 1. So now we're down to a choice of 2. So it's either 2 and 3 or just 3. Well, I know for certain 3. And because the mean and the median are not the same, I'm going to vote against number 2. Because to be symmetrical, the mean and the median must be the same. So I'm going to choose number 3 only. Okay. A dolphin travels through the water at a speed of 25 kilometers per hour. Which representation shows the distance a dolphin can travel at this rate? Well, the rate is represented by the dividing line. So 0 times 25 is 0. 2 times 25 is 50, 100, so it seems like our calculation matches. I like to have a data table to start with. Okay, so I would say that matches. Now, what this right here, this is the linear equation. It's based off of y equals mx plus b. This here is your start value. On the y axis. So if you were to graph this, B is the point where your line will cross the y axis. This is your input, usually of time. M is slope or your rate. And Y is your output. What is all of this worth together? So if we were to use the linear equation, we would have to have y equals (25x plus 0). Because this would be time, an input of time. And if time were 0, your starting value would have to be 0 because you would not have gone any distance because you spent no time going anywhere. And so we see that the linear equation we would have to have is different than here, so I would not choose that. Okay? Well, time, it's 25 per hour, not 25 hours per kilometer. So that's wrong. Okay, this is the way it should be. So after 1 hour, the dolphin would have gone 25 kilometers. After 2 hours, the dolphin would have gone 50. After 3 hours, 75. This is why we call this a linear function or a linear equation. Okay? So that is a graph. So I'm showing the graph of what the linear equation should be. It would look like that. So, just because the line looks right doesn't mean your graph is right. They're given distance values for time. That's wrong. This is over here, what I'm circling, is what your graph should look like if it were correct. And then in 5 hours, a dolphin can travel a distance of 135 kilometers. That's wrong, because if we just do simple, 5 over 1 hours times 25 kilometers per hour, and we cancel the hours. 5 times 25, 1 times 1, which would equal not 135. It would equal 125. So out of these choices of what we were given, I would go with the table. I would go with this table right here. All right. 2 more to go. All right, here we go. So there's a linear relationship because when we graph, that line will go right through our points. Every correct answer will be on the line and only on the line. If we end up with an answer over here, that's not on the line. That will not work. That is an incorrect answer. All right. So, let me clear off my annotations. Well, that's not going to work. That's okay. I have a backup plan. All right, so what I did is I just made the dots that we started with bigger. Okay, now these points that were plotted before I drew the line, those are correct because we can see it's right on the line. All right, so Layla read 2 books in the first 3 months. She was a member of the book club. So here's the number of months. Okay, so in the first 3 months, she read 2 books. No, that is not on the line. Let's look at the next one. Layla read 3 books in the first 2 months. She was a member. Here's 2 months. We come up to 3, and we see that that's on the line. We know that's correct because it's on the line. Layla read 3 books in the first 4 months. So 4 months, come up to 3. No. The last one. Layla read 4 books in the first 3 months she was a member. So here's 3. We come up to 4. 4 is close to the line, but it's not on the line. So we know that is incorrect. During migration, a butterfly can travel 30 miles in 1 hour. Which graph best represents y, the number of miles a butterfly can travel in X hours? So, time is always on the x-axis. The output value is always on the y-axis. So let's test this. Here we have 5 hours, right? So let's do so we should say that in 5 hours, no, that is not right, because in 5 hours, the butterfly went 150 miles. That is not on the line. Check this out. In 30 hours, so that would be 900. That's not even on our graph. So we know that not only is F wrong, but H is wrong. Let's check out J. All right. So time 30 hours. Again, that's not even on our graph. 900 is not even on our graph. So 30 miles per hour for 30 hours. The butterfly should go 900 miles. That's not even on our graph. Now let's take a look at this. In 1 hour, the butterfly should have gone 30 miles. In 3 hours, the butterfly should have gone 90 miles. G is our answer. All right. So, with a graph, the only correct answers will be on the line. If you plot a point that is not on the line and you've plotted correctly, you do not have a correct answer. If you plot a point and it is on the line, that is a correct answer, so long as you plotted correctly. Okay, same here. So, I like to set up a data table to begin with, and as it turns out, the data table we were given, that was our correct choice. If I'm given other representations and I'm asked to choose the correct representation, I'm going to start with a data table. I'm going to do the linear equation if that's one of the representations. I'm going to actually create, based on my data table, these other representations. If you need practice doing those representations, make sure you do the extra credit in this assignment. Okay. Now, the dot plots seem to have the most work because you have to calculate everything except for mode. That's just the way it's just the nature of the beast. And remember, a circle graph, the graph equals 100%. Now, if you're looking for a specific value, like how many minutes or how many hours, and the circle graph represents a whole day, 24 hours, then you're going to have to do some calculation. So I think with this, to go from a fraction to a decimal, you take the numerator and divide that by the denominator of that fraction, and that will give you the decimal. And if you want to go to a percent, you multiply by 100%. You multiply the decimal by 100%. If you want to go the other way around, if you want to go from a percent to a decimal, you're going to divide by 100%. We can cancel out the percent sign, so now it's just 300 divided by 100. Okay. And then to go to a fraction, you're going to take the decimal and you're going to place that over the place value. So let's say it's 3, right? Well, the 3 is in the ones place, so the fraction for 3 is 3 over 1. If it was 0.3, like this, then the 3 is in the tenths place, so it's 3 over 10. Okay. Remember, mean isn't really shown in the box and whisker plot. There's two kinds of range. There's the overall range, which we just call range, and then there's the range inside the box, and we call that the IQR. All right. Now, when you want to find, like, how much more is one category compared to the other, and you're given the value, you can just subtract the 2%. So this percent subtract that percent. You find the difference between the 2%, and then you take that and convert it to a decimal, and you multiply that against the actual value of that circle graph. Here, remember the height of the bar, you follow all the way over to the y-axis, and that will tell you the value of that category. Okay, and then you can use, once you have that, you can use that information to then answer the questions. Okay. And then if you are missing a percent, but you have all the rest, you just take 100%, subtract the sum of all these other percents, these other categories, and then that will let you know what the percent of the category you're missing the percent on. All right, and so that is 7.6G, 7.12A, and 7.4A.